Okay, this is your lesson on parametric equations. In this lesson, you will use parametric equations to understand the direction of a graph defined by its parameter. Eliminate the parameter in parametric equations. Write rectangular equations as parametric equations and graph parametric equations. All right. If you think about a ship that's traveling, and we're going to want to know the movement of the ship, and its west to east displacement, or going horizontally from west to east, is modeled by this equation here. H of t is equal to 2t. So the horizontal movement is 2t, where t is in time. Its south-north displacement, going vertically, is modeled by this equation. The vertical displacement is equal to 10 minus t. Complete the table. So if we want to complete the table here, we're going to use 0 for t. So 2 times 0 is 0. And then 2 times 1 is 2. And 2 times 2 is 4. And 3 times 2 is 6. And so on, right? Okay, let's fill in this table here. And then for the vertical displacement, it would be 10 minus t. So 10 minus 0, 10 minus 1, 10 minus 2, 10 minus 3, 10 minus 4, 10 minus 5, 10 minus 6, and 10 minus 7. Okay, and if we graph t and v, alright, if we graph t and v, we will get this point here, 0, 10 at time 0, and after 1 unit of time it will be at 2, 9, and so on, 4, 8, 6, 7, 8, 6, 10, 5, and 12, 4, and then this one, I don't have the graph large enough to graph that, so I'm not going to worry about that. But what that gives us is that over the course of time, from 0 units of time, like 0 seconds or minutes or hours, to 7 hours, the ship is going in this direction. Okay, that's what the parametric equations give us. Now, if you wrote this in rectangular coordinates, we know that this line is really y is mx plus b. It starts at 10, that's my y-intercept, and the slope is a negative 1/2. So it's down 1 over 2, down 1 over 2. That's what we are normally writing in Algebra 1. But in parametric equations, we would have this. We would have the 2t for the horizontal, and then the 10 minus t is my vertical. And in this case, we're only using it from 0 to 7. Okay, so these two are the same. It makes the same graph, except the parametric set of equations gives me a direction. All right, let's move a little more quickly here. To eliminate the parameter, to get rid of t, that's my parameter, we would solve for t and use the substitution into the other equation. We can do it either way. It doesn't matter which way we do it, but I'm just going to do the first one. So I'm going to solve the top equation. X is equal to 2t. Divide both sides by 2, and I get t is equal to 1/2 x. Using this and plugging that into the second equation, I get y is equal to 10 minus whatever my t was, which is 1/2 x. So, and at that point you need to simplify if needed. You can if you want, but that would just give me the other equation with the y is equal to 1/2, negative 1/2 x plus 10. Here's a little bit more complicated set of equations, but we're going to do the same thing. We're going to eliminate the t. So we're going to solve it for this t, and once we get that, we're going to plug it in here. So we're solving for this. First, I want to square both sides. So I have now x squared is equal to all of this squared. 1 squared is just 1. And the square gets rid of the square root. Now I'm going to do a cross multiplication. I'm going to switch these two here. And I get t plus 1 is equal to 1 over x squared. Now finishing solving off for t, I can subtract 1 from both sides. And there's my t right here. All done. I'm going to take this and I'm going to put it in both of these t's. Alright, so now if y is equal to the t over t plus 1. Doing a little math here with a fraction and a 1, I'm going to get a common denominator of x squared. So this x squared over x squared is my 1. Doing subtraction there. And then this cancels each other out, the negative 1 and positive 1. That just goes away, and that just gives me 1 over t squared. Now this numerator gives me this, and this denominator over here gives me this. Now my y is equal to 1 minus x squared over my common denominator over 1 over x squared. Now these two denominators can be reduced away. So now I just have 1 minus t squared over 1, which is just 1 minus x squared. Okay? So knowing this, you know that this is a parabola that opens down with the vertex at 0, 1. That's what this was. Okay, these two parametric equations is the same as this rectangular equation. And make sure you check that t has to be greater than negative 1. If it was anything smaller than negative 1, then this here would not work. Both of these would not work. Okay? Or at least this one won't work. Alright. So the original problem asked me to sketch this curve, so I'm going to sketch it. And notice that I said that this was t had to be greater than negative 1. So I'm going to go ahead and do that. So t is greater than negative 1. So let's try 0, 1, 2, 3, 4, and 5. Now putting that into here, I get 1 over 0 plus 1 square root and all that. I should get 1. 1 plus 1 is 2. Take the square root of 2 is square root of 2. 1 over the square root of 2 is 1 over the square root of 2 is 0.44, and since I'm graphing it, I'm just going to use 1 decimal place because I can't graph it any better than that. Now this is 1 over the square root of 3, and that's going to give me 0.577, so that's about 0.6 graphing it. And then this will give me 1 over square root of 4, which is 1/2. And then this will give me 1 over square root of 5, which is 0.44 again. And then 1 over the square root of 6 is 0.4. This is 0.45. So this is a little bit smaller. The y values, negative 1 over 1, I'm sorry, 0 over 0 plus 1 is 0. 1 over 1 plus, that's 1/2. and then 2 over 3 is 0.66. 3 over 4 is 0.75. 4 over 5 is 0.8. And 5 over 6 is 0.83. Okay, so graphing this, we're going to start at 1, 0. And then we're going to go to 0.4. You know what? I'm going to change this a little bit. I'm going to erase this here. And go back to my pen, and I'm going to put a decimal on all these because my graph is going to be too small. So these are all point somethings, because my entire graph would have fit in here if I didn't put a decimal, and that would not have been good. Okay, so oops, right there. This is 1.0, just like this is 1.0. So it'll be 1, 0, and then 0.4, 0.5, and then 0.6, 0.7, and 0.5, 0.75, 0.45, 0.8, 0.8, or 0.4 is 0.83. Alright, now looking at this tells me there's something wrong with this one here. So let me go back and look at that second one. 1 over rad 2 is 0.7, not 0.4. 0.7. This is 0.7, 0.5. That's better. Not that one. Okay, so this is going to look like this. It's going to be a parabola. It's going to come this way. And since I only go up to this number here, it's going to go like this. It never quite gets there. If I were to continue it, this would be an upside down parabola. It should look like that. Okay? Alright. That's a messy problem. But it was in the book, so I thought I'd show it to you. Alright. Okay, this is another one. Graphing this to make a table like we did before, using t's from -2 to 3, and you're going to get this, and you're going to see that this is going to be a parabola on its side, but using the parametrics, we will be able to see that the graph actually goes in this direction. It starts down here and it goes around this way and ends up over here. This is if you're using a graphing calculator. Okay, and we can play around with that in class. Alright. Okay, let's do one more before we leave this, because that one parabola problem with all the decimals was a little confusing, I think. Alright, let's go with this here. Let's start with number 9, and we're going to use let's see, this is just a line, so I'm just going to use, let's say, 0, 1, 2, 3, 4, and 5. When I use these for t, I just get 0, 1, 2, 3, 4, and 5. when I put those in for here, I get 0, -4, -8, -12, -16, and -20. Since my graph only goes up to 7, I can probably only do like the first 3 points here. 0, 0, 1, comma, -4, and 2, comma, -8. So there's my graph. And if I had chosen numbers like -1, I would have had -1, comma, +4. So I would have had -1, comma, +4, and so on. So I get this line here. And this parametric equation is going down this way. The most important part about this graph is this arrow, because the parametric tells me it's going down as t goes up. Okay. Alright, so there's some other ones in here that you can try. Those just involve a little bit more algebra. Okay. Alright, find two different sets of parametric equations for the given rectangular equation. So this is where people get all confused. It's the easiest part of the problem here. It says give two different sets. Okay, so I'll give you one set. One set would be just to replace the x with t. Then I just will go x is equal to t, put the t in here, so y is equal to 4t minus 3. That's my first set. I need a second set. So in that second set, I'm going to make something up. I'm going to go maybe like 2t. Let's try 2t. Let's put 2t. There is very few wrong answers. You can make up anything you want. That's the hard part. You know, where do I start? You're afraid to start because you're afraid to make a mistake. It's almost impossible to make a mistake unless you do some math errors wrong. So now if I say that x is equal to 2t, all I have to do is put the 2t word, the x's, in here, right? So that would be y is equal to 4 times my x, which is 2t minus 3, which gives me y is equal to 8t minus 3. This is my second set. See, that's not that bad, right? Okay, let's do 47. If we do the easy one, just let x is equal to t, then y is equal to t squared plus 4, right? Just put the t right here, like that. Okay, but then you have to come up with another one. So let's go x. I used 2t before. Let's make this a little more interesting and do 3t. All right, how about a negative 3t? I'm really excited here, so I'm going to try something really hard like negative 3t. So I put a negative 3t for x, so that means y is equal to where the x is. I'm going to put a negative 3t like that. Okay, simplifying that, y is equal to negative 3 squared is 9. Okay, this would be 9t squared plus 4. So there's my second set. This is my first set. Both these two are both for number 47. Okay, I need two different sets. That's how you get two different sets. Right, one super easy one not quite as easy, but also easy. Just a little bit of work. Okay, very good. All right, next. Okay, sketch the curve. All right, let's do some with trig here. Notice that we have x is equal to 3 cosine theta and y is equal to 4 sine theta. Well, my parameter here is theta, so I can leave this as sine and cosine theta. So first I'm going to solve for the parameter. I'm going to get it as some form of sine and cosine theta. So now I have cosine theta is equal to x over 3, dividing both sides by 3 to cancel this 3 and moving the 3 to the other side. I get this. And looking at this, I'm going to divide both sides by 4, canceling that 4, put the 4 on the other side, and it's going to look like this. Okay. This part just tells me that my theta, or t is between 0 and 2 pi. All right. So we need something that relates cosine and sine. Well, the Pythagorean identity relates cosine and sine together. That means if I square this plus squaring this gives me 1. So that's exactly what I'm going to do. I'm going to square the x over 3 plus the y over 4, square of y over 4. That's just the cosine squared and sine squared. And then we just simplify that a little bit, and we say x squared over 3 squared, y squared over 4 squared, and equals 1, and that's my rectangular coordinates. And we've eliminated the parameter. Now we know that this is an ellipse with a vertical major axis of 8 and a horizontal axis of 6. Okay? All right. Next. Okay, let's try this one here. All right, we're going to do this like we did the last one. We're going to solve this for cosine. So I'm going to divide by 3. So that means cosine theta is equal to x over 3. There's one parameter. And then I'm going to solve this and divide this by 3. And I'm going to get sine of theta is equal to y over 3. And I know that cosine squared plus sine squared, cosine squared plus sine squared is equal to 1. That means that x squared over 9 plus y squared over 9 is equal to 1. And I recognize that this is a circle, so I'm going to multiply through by 9. And that will cancel these, so I'll get x squared plus y squared is equal to 9, and that's my circle. Okay, all right. Okay, make a t table, put some t's in, and you can get that one. All right, so I want to move on to the assignment here. Okay, this worksheet. We're going to put some numbers in here. Let's see, -2 squared is 4. So this is radical 5, and radical 5 is just 2.2. Oops, pardon me. This is just 2.2. And then -2 minus -2 is 4. And I'm just continuing filling this out. So -1 squared is 2. Rad 2 is 1.4. 2 minus -1 is 3. And I notice that this is going to be 2, 1, 0, -1, -2, -3, -4. This is going to be the square root of 1. This is square root of 2. This is the square root of 5. And this is the square root of 10. This is the square root of 17. This is the square root of 26. And square root of 37. Okay, graphing these on my graph, I go 2.2, 4, and 1.4, 3, and then 1, 2, and then 1.4, 1. You starting to see something here? This is 2.2, 0. So, whoa. 3, 2, 5. Ooh, these two are too high. Sorry about that. eraser. Let's get rid of those two. Alright. And then let's see. 3.2, -1, to 4.1, -2, 5.1, -3, and 6.1, -4. So I get this thing going on here. Make sure you put the arrow to show that it's going down this way. And it says we have to stay between -2 and 6 for my t. Do not go past 6.1. It stops at the 6.1. Okay, that's the last point. The arrow does not tell it to go on forever that way. There's a beginning and an end. It ends here, but the arrows just tell me which direction this parametric graph is going. All right. Number 2. So it says eliminate the parameter. Okay, so all we're going to do is eliminate the parameter. I'm going to take these two and switch them out by doing a cross multiplying for my proportion. And I get t minus 2 is equal to 1 over x. That means that t is equal to 1 over x plus 2. Putting my t into my second equation, I get y is equal to 4 times 1 over x plus 2 plus 5. Distributing the 4, I get 4 over x plus 8 plus 5, which really is 4 over x plus 13. Alright, so you can see that these two are going to be similar. I'll let you do those. Yeah, they're not that bad, right? So add the t to that side, subtract the x, and then plug it in here. And then this one, subtract the 4 and times 2 and put that in there. Alright, I'll let you work those out. Alright, I'm going to be doing this one I already worked out earlier in the video, so I'm not going to work out again. If you forgot, then you need to rewind it. Okay? This one is the honors one. So unless you know your double angle identity, you may not have to worry about this one. Okay, and then let's try this one right here, number 7. This one's already good. I'm going to leave that as my parameter on this side, and then I'm going to divide both sides by 2 here, so that y over 2 is equal to sine squared theta. And that means that cosine squared theta is equal to x squared. So now if I put them in my Pythagorean identity, cosine squared theta plus sine squared theta is equal to 1. That means that cosine squared is x squared. Sine squared is y over 2 is equal to 1. What is that? That is a parabola, so I want to put that in standard form. So first, let me move the y minus 2 to the other side, and I get x squared is equal to negative y over 2 plus 1. I'm going to factor out a half. Okay, if I factor out a negative 1/2, I get y minus 2. Okay, if you don't believe me, you can distribute this negative 1/2 to the negative 2 and you should get 1, right? Alright, so now this is my 4p here. Remember that your standard form for a parabola looks like that, right? 4p, which is the length of your lattice rectum. Okay, so we have a vertex of my parabola at 0, 2, and 4p is equal to negative 1/2. So it's opening down. So the parabola looks like that, okay? With the vertex at 0, 2, right here, 0, 2, and the focus point will be 1/2, or let's see, 4p is equal to 1/2, negative 1/2. So p is equal to negative 1/8. So this is negative 1/8 down here, negative 1/8. That's your focus. So in case you forgot, if I add a negative 1/8 to 2, I get 1 7/8. That's my focus. This is my vertex. Alrighty. Okay, write 2 sets of new parametric equations. Let's do that easy one. I'm going to let x is equal to t, and then that means y is equal to t plus 2q minus 4. There's 1. Now it says 2, so I need another one. So let's say I'm going to say x is equal to I'm going to say 4t, and I'm not going to let you use 4t. If you put 4t on the homework, on your worksheet, because you're copying it directly from the video, I'm not going to count it. Use something other than 4t, alright? So then putting my 4t in the other one, I'll get y is equal to 4t plus 2 cubed minus 4. Okay, so then that'll be y is equal to 4t plus 2 cubed minus 4. So that's 1 and 2. So I need 2. So do the same thing for that one. And I think I'm pretty much done with this video. Yeah, I think this one you need to think about it and then describe your thought process for solving for t. Alright, that's it. Adios.